Hi, I'm Sunday Sylvester, and in this video I'm going to discuss some graph. So first, what we're going to be doing is that I'm going to give introduction to graph. I'm going to give you the use of graph, why do we use it. Also, I'm going to talk on mass graph and give example. Mass graph is such very simple and very straightforward. To a point that one of my teachers ever told me that mathematicians don't know graph. So, but that's good starting point. But the real graph you want to be learning, or if you know it, you are good in graph, is actually a physics/chemistry graph, which I call the real world graph, right? Because you do practical. It's not that the table of value will be given to you as perfect numbers. So continue, I'm going to give you a formula. I think two formulas which you may use, because during my work I'll tell you the story later. During my work it helps me a lot. So that's what we're going to be doing today. So first, introduction to graph. So graph is something like this you can see in the screen. At first you'll be given a graph like this, and those numbers you see here won't be there. It's going to be very hard for me to write those numbers. That's why I put it already before I start the video. So once the graph is given to you like this, you have the vertical axis and the horizontal axis. So the vertical axis from up and down is actually your y axis, while your horizontal axis is your x axis. Note that in some practical that you do, you won't be given y, you'll be given something different like length. So you're going to use L, and it puts the units there in brackets, like say L in meter or L in centimeter. If it is current, you say I, that's current in ampere, right? Be putting the unit in brackets so that you tell somebody interpreting your graph what you're doing. Also, the horizontal axis, it can be different thing, right? So just x and y is the commonly used in math, because we're not doing graph and we're not doing practical in math. It's just table of value they give you to plot it. So I'm going to be using x and y, but once we come for a position to use a practical one, we're going to use the real symbol there and the unit, not x and y again. And again, so when you draw it, there's one thing very important. Then you draw a line from where you are cutting it. You draw a line like this, a thick line on it, and draw an arrow like this, right? I failed to do that because it's shaking. It's actually shocking. I have reason for not doing it, but this is something you suppose you do for the first time. You start this line before you write it. In some cases, some people don't like writing on the last line because sometimes it looks dated. So they pick a point in the center, right? Let me pick this one and this one. So they pick it like this. So their numbers will be written in this place, right? It will be written in this place. You understand what I mean, right? But this graph is actually too small for me to do it in the middle, so I prefer taking it from the center. So that's also very important, you should know. And again, why do we use graph? Well, it's actually simple. One thing I want you to understand is that when you do an experiment once, like simple harmonic motion, when you swing it, measure your periods and the length, you can use it and calculate your value of g. Straightforward. Sometimes you don't even really need to oscillate it for like 30 times. Just once is you're done, you get your answer. But the problem is that in nature we have a lot of resistance. Our accuracy, right, is too low, right? So what we're going to do is that if we do more, I take the average to approximately give you close to the real answer. If you do more, right, you know, average, right? If you do more, the more you're doing, it actually give you the plenty you do, and you take the average, it's actually going to give you the closest answer to the, because you do some practical, you do some practical, and when you do it, maybe the answer is too high, and doing the second one maybe it's too low, do the third one it's a little bit low, do the fourth one a little bit high, as in the numbers will be scattered. But once you finish it and you take their average, right, so that's graphing, and take the average now, so then you're going to get your answer that is very close to the real answer. If you do graph, plot a graph of just let me say 5, you just do it 5 times, and somebody do it 10 times, so the answer for the person that did it 10 times will be more closer to the value, let's say acceleration due to gravity. So he may be getting 9.87, while you'll be getting something like 9.72 like this, which is a little bit not okay. But if you just do it only once, you may get something like 11.2 or something like that. So actually 11.2 is too big, it's wrong, right? So the more you do, the plenty you do it, the more your answer is cool. So that's the use for graph. We use it like just just to get the average, like that's why some graph of some question, if they give you, they ask you repeat this experiment for the value of this equals to this equals to this equals to this. They give you plenty of them, like 6 of them, right? And they'll first give you the procedure for the first one, and then give you another 6 ones, say repeat them. Actually, you're not just wasting your time, they want you to do it and get the much accurate one, right? So that's the use of graph. So I think we understand it. So don't just neglect it, don't think it's stressful. It's actually very important. Once, especially even in medical field or anything that have to do with okay, calculation of variable numbers like this or experiment, you have to work with graph, right? Because some computers also read in graph, right? So all of those things, please, graph is something you calm down and understand it, right? So the next thing is that I'm going to go for mass graph, right? I'm going to talk on the graph, on the standard of mass. So the mass graph is very simple. Mass graph is very simple and not something hard to learn. So let me get back my graph again, and I will let me explain how it is. So let's say this is our mass graph, and this is our y-axis, and this is our x-axis, right? So when you're doing something like this on mass, we'll be given a table of value which we're going to be plotting it. Let's say this is our table of value, right? This is our y-axis and this is our x-axis. So let's say when y is equals to 1, x is equals to 4, and when y is equals to 5, x is just equals to 6, and y is equals to let's say 11, y is equals to let's say 8. Right, I'm just bringing number from my head, right? I just want to just pick a number so that we can get the point easy. So how do we do it now? Look at how it works, right? This is the foundation, right? This is very easy. The problem is the physics one, right? This is very easy to locate anything in school here, so I don't want you to get confused here, but we need this one before we go down. So look at it. How do we locate this thing? So you go for the y, right? You go for y-axis and say when y is equals to 1, look at it here, y is equals to 1. You checking? Let me put a blue. My hand cannot be this on, yeah, that's the one I'm picking, right? And we say x is actually equals to 4 and x is actually equals to 4 here. So where do they meet here, right? Where did they meet here? So they meet here, right? My hand is not, that's where they meet. And again, when y is equals to 5, where is 5? Here is it. X is equals to 6, x is equals to 6, here is it. So where did they meet? You can follow it here. When you're doing it, here is it. Here's it. This one. Yeah. This is actually the one I'm talking of, right? Hope you can see it because the way I'm writing, I'm using my hand, so very hard for me to locate the line. The line is too tiny. So again, when y is equals to 11, y is equals to 11, here is it. Is it? So x is actually equals to 8. Is it? So x is already very clear at that, and 11 is like this. So there's it here. So you can see how it can look like. So when you have something done like this, we have your points there, right? So you pick your points, you put a point on your where they meet. Some people put star, used to put star on it, used to put star on it, used to put star on it. So now we're going to draw a line and connect the two guys, right? We're going to connect the 3 people, so you can see how it is, right? So it connects these 3 lines there. The more you do, you may hang up plenty like this, right? If you do plenty of them. So that's how the graph will look like. So as I say, this mass graph, right, very easy to graph. You just say where's y, tick, where's x, tick, where's this. Very easy to do it, right? How about if this our x-axis there, right? We can see that it is not in 1, 2, 3. They're not in integer. They're actually in even number. How about if we get odd number? Let's say we get odd number 9. Let's say we get odd number 9. How do we go about it? Let's say we get 9. Well, it's also easy to do it, but here we have to do is that we go to, since from 8 we go to 9, so we know that actually 9 is actually the middle, right? 9 should be the middle, right? So if we're comparing 9, let's say 9 and 8 here, so this 8 and this is 9. 9 is actually the middle of these guys, right? So this is it and this is it. So 9 is actually the middle, so you pick it there. Well, all of this is kind of crazy, but I think you're understanding what I mean by locating their values, because my main problem here is just to locate the values here, right? I'm going to teach you how to do the rest, the difficult one using formulas, right? So here I just want you to locate the values here. And this thing will going to be very hard for me because my hand is too big for the screen to pick my hand here. So now let's go into the next thing here. I don't want to waste time mask this one, but since we have already seen how I locate their numbers, I think it's very easy, right? But let me take one mask one mask graph again and explain the formula I'm going to use, right? So the formula I'm going to use is very easy. At first, you're going to count the number of boxes in the small box inside one big box. You know, when you have the graph look something like this, then you have one big like this, right? So you also have it like this, you have a big like this. So this is how the graph look like. So you count the number of boxes inside it, right? Normally it's 5, right? 1 2 3 4 5. Yeah, normally it's 5, but just count it for counting sake, right? So you count it because some graph would take it to 10 before striking the big one. So it's very good for you to count it first. So now count it, and that's your number of boxes, right? Box equals to 5 for this case, right? If your graph is too big and the box is equals to 10, write box equals to 10, right? So for box equals to 5, now the next thing we're going to do is we're going to find the value of each box. What does each box mean? The value, as in what does each box carry, right, when doing it. So the formula I use for A is just B, each box, yeah, that's small b, is actually equals to the first number, which I just write as F, with the first value there, right, in your graphing, right? If you do the graph something like this, and if it is like 2 4 6, the first number is the 2. If it is 1 2 3, the first number is 1. If it is 10 20 30, the first number is 10. That's how it is, right? So from the 0, the first number you meet at that axis. If it is here, if it is 2 4 6, the first number on this horizontal axis is actually 2. I think the first number is not something hard to graph. So first number divided by the numbers of boxes there. Number of boxes in small inside a big box, right? Number of boxes inside a big box, right? So let's say the first this thing number value is actually 2, so we get 2 divided by 5. 2 divided by 5 is about 0.4. so each of the box is 0.4, right? So you take note of that and keep it in one place and write it. B is equals to 0.4. And again, next formula I'm going to use is very easy. It's just telling you that the point P is equals to the value from your table of value. That's the one you pick, right? Like, let me say I want to know the value of 7, where I want to locate the value of 7 on x-axis. So that's your V. Let's say you want to locate 7.2. That's your V. Right? Anyhow, what you want to locate, the value you want to locate on your graph is the V, right? So that's the value V. So minus the last time. Last time is actually the last time, as in the term that you see that is less than, is the least one, right? Then is the immediate least value than the value you pick. Let's say you have your graph like this, and it's coming here. You have 4, you have 5, you have 6, you have 7, you have 8. You can see this is 7.2. So the least number is actually 7 before you get to 7.2. So just telling you that 7.2 is actually between these two guys here, 7 and 8. this is where the confusion used to come. But I think if you somebody understand, it's very very easy, because it's just like, okay, let me take another example. Let's say I'm using 2, 4, 6, 8, right? 2.68. So like say I'm looking for the value of same. Okay, let me say 5.2 in this case. 5.2. Actually, 5.2 is between this place, right? Is less than 6 or greater than 4. So should be between here, and the last number before you made 5 points is actually 4, right? Not 6, is 4. 4 is the last number before you go to 5 points something. So the last number there is 4. As we continue doing it, you will come and understand this place very very well, and if you've already understand it, I think it's something cool. And so let me give the formula so we can continue. So a value minus the last time divided by b, that's all. Because this is the formula. This formula is very easy for you to work with it, because if you want to because you already get your v and your b is constant for that axis, because the number of boxes is still the same, and the first number is still the same divided by the number of boxes there, right? So the same. So the value of each of the box in that axis, whether the y-axis or the x-axis, is remain constant. But once you do for x, you have to do for y as well, unless if their scales, right, is the same. If the scale is not the same, maybe you take 2 centimeter to represent 1 unit, or 5 centimeter to represent 5 centimeter to represent 1 unit. And how you do it, if the scales is different, your b will be also different. So for x and y, so find for x and locate the point, and now go and find b for y, and now locate the point as well. So let me tell you what happened, very important, so that you can pay attention to this formula. When I wrote my work or 2020, we have a graph, I think is it physics or chemistry, I can't remember exactly which subject is that, and I think it's physics. So, and when we plot the graph, we plot everything is cool, no any mistake, very fine graph. And when we are answering some questions below it, they said we should find the intercept of the graph to the y-axis. Let's say this is how the graph look like. So when we draw it, we actually, let me draw it the whole cool way. This is how we do the graph, right? But when we put our table of values, we graph everything, our graph looks something like this. And this is the whole of our page. Let's say our page is like this. We use the maximum space, right? You understand what I mean? So this is our edge of our space, and they ask us to find the intercept with this or with y-axis. So we need space like this where it come and intercept here, and it will intercept outside our book. And you cannot, even if it is inside a book, this is where our graph stop. The scales didn't continue to this place. It's even much bigger than this place, because I remember I have to use graph something like this, very long distance from where our book ends. So the problem is that our graph is too small. We draw it very well, but we didn't know that the thing will actually intercept some distance away from our graph, because all of us want to draw a big graph, and it's always advisable you draw the biggest graph you can, because uh, the the bigger it is, the more accurate it is, and also the bigger it is, the more the examiner sees things very well and mark you good score there. If you draw a very tiny graph, or you draw big graph and draw tiny slope, some people will even wrong you, because where I give certain distance, certain lengths of your scale, right? If your scale is not that long, they'll wrong you. So please and please make sure your graph is big, and make sure your scale, your slope is also big. You can see we're trying to make it big, and we now fall. I say trap. So what I did is that actually I have this formula with me. I drive this formula trying to teach somebody how to plot graph, because as I'm teaching, person is suffering to understand it. So I now develop the formula and the process of doing it. So in my work, when I want to use it, this is where I come from. So when this thing happened, the teacher said, we don't have time, let's go to go to another thing to do. Don't waste your time on this graph again. Don't clean it, as in just move on to other things and do and help your life with this. You know what I do? I carry my eraser. I clean everything. I clean the graph. And I shifted the graph. I cleaned the graph from here and I shifted it up, right? I shifted it up. When the teacher saw me, it was like, Sunday. I didn't mind. I said, I'll do it. You know what I do? When I just get my B, I write it in one place. I'm telling you, we just my calculator. I'll just pick the value. I just say the value minus the last time I've seen there. I just press it, divide by the B. I'll just say bam, 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 bam. This is where I'll just count it and say this is my point. And it's practical graph is something hard for you to locate it. I've searched for scales, table of value for a simple pendulum. You'll see how difficult it is to locate it. So when I'm doing it, I'm telling you, with ease and fast and accurate, no waste of time, I was able to draw my graph back, and it intercept exactly at the point our teacher, our teacher now puts another graph below our real graph and measure it to the point it's going to meet. Then just pick the value and answer the question there. It's not intercepting on our book, but intercepts on the ones he used. The ruler or another things you use like this way, you measure it. So my answer gives the same value as it got. My own has an intercept on it. So what I'm saying is that this formula will be very useful for you when you want to do a fasting. The problem is that when you want to be counting numbers that have to be with 0.20 decimal, you have to be doing it one after the other. This plus this plus this plus this plus this until you get the answer, and it's very, very hard for you. So, and also once you get your answer, they give you something 0.5. You just know that it's actually the middle, right? Let's say this is the box, right? You pick the middle of the box, right? The middle. I'm trying to draw the middle here, right? Take the middle, and if you give you 0.9, then you pick something like this, right? Something like this. I mean, close to the last point here. You understand? So yeah, we're gonna go for it. So without waste of time, let me take as I said, let me take one mass graph again, and let's do it. And after this one, I'm going to show you how to take the scale first, how to produce a good scale on yourself to answer a question that is kind of deep. So here is it. Now for this graph here, we have x and y. Now let's talk on x axis, because x axis is a bit complex more, because it's 2, 4, 6, 18. So if you count the number of small boxes in this big box, look at this big box. This is actually a big box, right? So the small ones inside, if you count them, you get 5, right? I can count it. 1, 2, 3, 4, 5. Yeah, 5. So that's the boxes there. Actually 5 in number. There's a small boxes. So that's our b. That's one value of a box. It's actually here. Yeah, we have the first value divided by the number of box. And the first value is actually 2 divided by number of box. It's actually 5. And I think we have already made example with this one, and we found that the b is actually 0.4, right? Let me clean these ones and save it there. So it's actually b is 0.4. So now next thing again, it's just table of value, right? Let me create good numbers that we will be using. Let's say we're going to locate the value of 5.5. We're going to locate the value of 6.7. Going to locate the value of 8.1. Going to locate the value of 10. Going to locate the 10.0. Let me write like this. Locate the value of 12.8. Okay, the value of 16.3. So I think this is okay, right? Before we finish that one, I think good example understand is there. So remember the formula. The formula, I say the point is actually the value minus the last number all over b. So let me first start with, we want to locate 5.5. So the point we're going to count there, this p is actually the point you count from the last time there. So the value is actually 5.5 minus the last time. Now the last time is what? Is actually 4, because we don't have 5. You understand? We have 4. If you check 5, we don't have 5. Be going down, right? If we don't have 4, if it is 3 there, then 3 is the last time. If you don't have 3, then 2 is the last time, right? Just the last time before you enter that 5 point something. Not something greater, you know. Don't go with something greater, because 6 here is greater. So I'm not going with 6, right? So 5.5 minus 4 divided by the b there, which is 0.4. So the point give me here is actually, a price calculator, 5.5 minus 4, get this divided by 0.4, I get 3.75. 3.75. That tells you that you're going to count from 4 from the last time. 3.7 is actually greater than 3.5. So the next box after counting 3, the next box you pass half with it. So it's very hard for me to locate it, but let me try it now. So I have 1, I have 2, I have 3. Then now the fourth one, I'm going to pick the middle here, right? Yeah, that's it. I don't think it's very hard for me to do it, but I think, thank you. I'm zooming it. Let me clean it again and do it again. So here is it. Thank you. So now from I have 3.75, right? So this 1, this 2, this 3, right? It's still actually on this. So the next one, I'm not going to come on this one. I'm not going to go for 4, but I'm going to pick the middle, right? So that's where it is. A little bit greater than the middle. If I'm going to pick, I'm going to pick somewhere like this. You can see it's kind of like close to that last next line, then to the former line here, right? So that's how it is, right? No stress. Easy. So now let's go to the next value. Let's go to the next value is actually 6.5. 6.5. 6.5. So 6.5 so 6.5 here. Yeah, so 6.5 we have 6.5. I don't have space, right? But let me just write them down there, right? Gonna be very big here. So P is actually value minus the last time is L over the B there, right? So the value is actually 6.5, 6.7 I mean, minus 6.7 minus the last time. The last time is actually 6, because you start counting from this, from the number there, because you know that 6.7 is between this place and this. If to say 6 is not here, I'm going to go for 5. If 5 is not there, I'm going to go for 4. You understand it, right? So start from the 6, so that you know that it's actually between this one and this one. So the last time is 6. So 6.7 minus 6, you make this, then divided by the B, that's 0.7, and I get 1.75 again. So I'm going to count 1, and the next one I'm not going to reach 2, but I'm going to stop at 7.5 here, right here. Thank you. So that's how it is. Some school. Oh, so we have brought lights. So let me get things. So we have already know the formula from our heads. Now let's go quick and do the other points, right? I'm just going to be using so I'm just going to be using the my calculator here, right? And you can see how fast I will be. So the next point I want to select is actually 8.1. 8.1. So 8.1 minus the last time is actually going to be 8. So minus 8, then down divided by 0.4, which is 0.25, less than even half. Less than even half. So it's just like a quarter. So I'm just going to pick something close to, oh, this is very big, thank you, something like that, right? I'm going to pick it very close to the 8. So now the next thing is actually 10. 10.0. 10.0 is actually this, right? So you're not going to count anything, because say 10.0 minus the last time, which is the same thing as 10, is actually 0 divided by 0. This is 0, so you're not going to count anything. So you can see it's working everywhere. So the next one is actually 12.8. Now 12.8 minus, yeah, we have 12 here, so minus 12, you get this. Now divided by 0.4, you get 2. I love this one. So from 12 we're going to count 1, 2. So it's right on this 2 that you're going to go with your value. And the next one again is actually 6.3. So 16.3. 16.3 minus the last time is also 16. Yeah, divided by 0.4, which is actually 0.75. 0.75. 0.75 is actually not even up to 1, so I'm going to pick close like this. Thank you. Now let's take another one. Let's take like 17.9. 17.9. I love this one. 17.9. So 17.9 minus the last time is actually no 7 here, and we'll go down 16. Yeah, so from 17, because we don't have 17 here, the last 9 we're going to be 16. If you don't have 16, we'll go to 15. If you don't have 15, we'll go to, that's how I think it's simple, right? So 17.9 minus 16, give me this divided by 0.4. So I get 4.75. So I'm going to start counting. 1, 2, 3, 4. Now 0.75, which will be now very close to this. That's why 17.9 is very close to 18. So it's just very small thing is going to land on the 18 itself. I think this thing is very easy and up to grab it, right? So you can see the formula is a bit simple and easy to memorize. Let me write it clear. It's that first b is equals to the first value divided by number of boxes. If you get this one, you just write it down and chillax with it. Then another formula is just b is equals to the value minus the last time divided by the b there we got. So that's all. The rest is just punching your calculator. I'm getting it fast. Because look, if I say I'm not going to use a calculator for this, right? For example, let me start with the first one here. I say 5.5, right? I say 5.5. Where did I locate it? Let me do it again. 5.5 minus 4, that was 0.4. I say 3.712 10.75 here, right? So something close to this place here. So now let's say I don't want to use let's say I don't want to use let's just I have to keep it like this. Let me write on this place, right? Let's say I don't want to use the formula. I want to just use my brain. So look at what I'm going to be doing. So I'll say 4 plus 0.4. So I'll say 1. That's how we used to do it. So it's not up to 5.5. Then I'll say plus 0.4. It's actually 2. This 2, and it's also not up to 5.5. So I'm going to say again plus 0.4. It's 5.2. Now 3 up to still less than 5.5. So say 0 plus 0.4. 5.6. No, 5.6 is greater. So I'm going to pick close to it. And you can see I've also get the same thing the way I got there. So will you continue doing it one after the other, be adding it to your calculator, or just punch your calculator using formula and just count 1 2 3, then get the other 0.7 close to that one there? I think it's very easy when we use the formula, right? So now let's go to our real world that we're going to use, our graph from physics practical. So here we have practical of physics, which is the practical is already done, and we just have the table of value. I'm going to plot it. I got this from the internet and it's actually legit. So let me explain what it means more before we now plot it on the graph. So here, this is actually your period, t square. So after getting your period, then you square it. So these are the values here at the first place here. This uncertainty about your error or anything like that, but we don't need it here, right? This level, we don't really need it. And again, this is your absolute uncertainty. Again, we don't need this one. And now the length in meter. Sometimes if you do your experiment, your length will be in centimeter, but in your when you're doing your graph, I prefer you go with meter because your G is in meter per second square, not centimeter per second square. Sometimes we normally get the answer in centimeter square before you convert it to meter square if you use your length in centimeter. But it's not that cool because the answer will be scary and some people will forget to convert it and think they're wrong. So make sure anyone you use, but remember to convert the end and tell you that it's meter per second square. But the easiest way to do it is just work with it in meter. So this is our length in meter. So we're going to plot our length in meter with our periods in square against our periods, the square of our periods there. So we're going to be checking their values and going. So one thing I discovered is that this length is actually progressing. It's just like a mass because you set it yourself. That's why the numbers are not crazy. So you can see from 0.1, 0.2, 0.3, 0.30, 0.40, 0.50, 0.60, 70, 80, 0.90, and 1.0, right? That's 100 centimeter. So we don't have problem with that. It's just like a mass graph, right? Because you do it yourself, you put the value yourself there, right? So just like a mass graph. So coming to this period, these are actually the craziest number there, right? These are the numbers here. You have 0 0.56, 0.9, 0.9, 94, 0.130, 1.1.30, 1.75. You have crazy numbers that are not actually in line. So what you're going to do, so first thing is actually your scale. Your scale will be very difficult to get when you're using numbers like this. But one thing I want to tell people is that scale, when you want to do scale, any number any scale you pick going to give you a correct answer, any scale you put. But the problem is that we really want to pick a scale that can have at least some of our some of our value in it, so that won't be approximative. You can see when it is like 0.75, that 75, I'm not that accurate in selecting it, or 0.25, I'm not that accurate in selecting that point because I'm just guessing that it's close to this place, close to this. But once it is like on that like 10.0, I'm just going for the 10, right? You can see that it's actually on the 10. I'm going to strike the line without any doubts. What I'm saying is that if your scales can get let's say on your scale you have 1.75, just like in here in this place, 1.75. So I don't need to approximate anything. But if it doesn't have 1.75, let's say we have is half or only or close to 1.75. So I'll be like 1.75 is this place in this place to this place, right? Just like the ones we'll be doing. Actually, you understand what I mean there, right? So scale is actually cool. It's very good for you to waste time small and choose the right scales that will fit into it. Most of your things there, and that's where the problem comes. This is the most difficult place thing to do in graph, right? The scale. But I say any scale can work, so you are free. Yeah, you are free, but your graph will not be that accurate if you use any scale. but you don't use any scales at first. Let me just state this clear. At first you have a rule that will guide you on where to go. First you pick your highest number, because you can't draw a graph that you can just give a scale that you find out that your some values could not fit into it. Like let's say here we have something up to 4.08, and your scale, the highest number your graph can take is just, let's say, 3.8 something. You can see this 4.08 cannot fit into the graph. Do you mean we should eliminate it? No. So you adjust your scale to make everything fit into it. And the first thing to do is that you're going to count your number of boxes, your number of big boxes, right? The number of big boxes, and the axis you're going to plot it. So once you get it, let me bring the picture so we can be using it together. I'm not concerned with the or other side. I'm just concerned with the horizontal x axis, because that's where our that's where the mine is. So look at it here. You're going to count your, it's different from for different graphs. That's why I always prefer you count for your graph. So when you're watching this video, the graph you're using, make sure you count it, and I prefer you get different graph so that you will learn it in different graph also. It's not just used to only one, because some example provide for you their own different graph formats there. So learn everyone. So you're going to count your big uh, box. So you have 1, 2, 3, 4, 5, 6, 7, 8. This is actually 7, right? 8, 9 is here, and 10, right? Thank you. It's just 10 dots, right? So it gives us 10. So now what you're going to do is that you pick the highest number here and divide it by 10. 4.07 divided by 10, you get 0.408. This is not actually a number you're going to use or what, but this is actually telling you that this is actually the smallest scale you can use for this thing. Because if you use something smaller than this thing, actually 4.8 won't fit here. It will be greater than here. It will be somewhere around here. So you have to use either this thing or something greater than this one, so that it can be either at the exact thing, that's the 4.08, at the exact thing, or something less than it. Anyone will be accepted, right? But sometimes it's not good for you to use it when it is very close, like compact it here, like just use your graph from here to here. No, it's not good. You have a lot of space, so make an adjustment so that you can consume somewhere around this place or something around this place. Minimum should be this place. Just waste like only 2 boxes there, right? Don't waste too much boxes. If you compact them together here and you're putting your dot here, and you're putting your dot here, and you drop small graph like this, it will wrong you. So make it big, right? Make your graph big and neat. So so that's for the first one there. So you have 0.408. So now when I'm doing this thing, I want to bring out the scales. I prefer I should use the whole of the box is there. That's the smaller box so that I can get good box and good value there. Before I used to use the big boxes there, but this time I say let me use smaller boxes as well. So what I do is that now for smaller boxes I now have 10 big boxes, and each of the 10 big boxes has 5. So that's tell you 5 times 10 is actually 50 small boxes you have from here to here. So 4.0 this divided by 50, I get 0.0816 0.0816. Well, 0.0816 is actually cool. But how will you put your skills? I'm trying to develop the skills get out so you can see how I'm thinking about it, right? And how you do it, because I tell you this is actually the main problem, right? The scaling problem, how to bring it out. So now I have 0.816. I can use this value, right? I tell you I can use it. My answer will still be there, my graph will still be correct. What I'm trying to do is just to get the one that will be simpler and have things, at least some of them fit into it. That's all. But if you don't want to stress yourself on it, please don't disturb yourself on scaling. Like in my exam, I don't disturb myself with much getting accurate, very good scale. Yeah, it should also consume mark. It has good mark there, but it will waste your time sometimes and even your energy, and you'll be cleaning things anyhow like that. So when you just get this value, that the maximum value you can get is actually that in the graph, just reduce it small, be reducing it and see how it fit though. Well, look, if I can use, I say we have 0. Let me get the number again. 1.08 divided by 10, so it's 0.405, right? 08, I mean. So 0.408 now plus itself, 0.0408, right? I get 0.816. I have that. No. 1.22. I don't have that in my scale. I'm checking the table of value now. Yeah, right? You can look at it. So well, I have 1.22. No, they are not inside. Go to the 1.732. No. 2.04. No. 2.44. I'm continuing adding 0.4082 to it, right? I've already set my calculator, and I'll just be pressing answer. It will be adding for me. That's why. I have 2.85 no. 3.264 nope. 3.61 nope. 4.08. That's the last one that could fit into it. But I tell you, all of them can work, right? All of them can work. Believe me, you can get your graph very neat when you use these scales as well. But how do you use this scale to put that to be writing those numbers in 3 decimal places? I don't like using 3 decimal places, so we have to round it to only 2 decimal places. And let's say we're going to use 0.41. I think this is actually greater than 0.408, because we need actually numbers that will be a little bit greater than that one, so that our graph will be the last one will be inside, right? So remember, if you use smaller value, the graph will be very big, right? So the space will be very big, so your your last number will be actually be way beyond your space of your book, right? Space of your graph book. So let's use 0.41, right? So now it's plus 0.41 again, and let's check which answer are there. Yeah, 2.1.6, 2.05, 2.46, 2.87, 3.28, 3.69, 4.1. I've already reached that place, right? So I reached the maximum number. I don't need to continue checking other usual things like that. Well, so that's how we find scales, right? But I think when I'm drawing the graph, when I'm preparing for the lesson, I use a scale of 0.4, right? 45. I think I use scales of 0.45. All will be fine, even though you use 0.41. I want to use 0.41 also, but the problem is that I've already designed it with 0.45. But I prefer you also try it with 0.4. It's also going to work, right? Table of value scale is not something hard. Don't take it hard. It's very easy, right? But try to get this one that will be sweet for you. At first I said take the big one, divide it by the biggest one, divided by the total number of boxes you have, and you get your answer. So for this place is actually 4.08. Now divided by 10, I have 0.408. So what I'm trying to do is to get a scale either greater than this or equals to this, not less than this number, not less than this number for each box. So that's it. That's what you're gonna keep the back of your mind. So now let's go to the next thing without waste of time. Let's plot it. But at first, let me write this as numbers on my book so that I can get to the graph well. So the length we have 0 0.1, 0 0.2, 0 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. As for c square, I have 0 0.56, 0 0.94, 1.30, 1.77, 2.10, 2.56, 2.9, 3.24, 3.61, and 4.08, right? That's how the thing look like. So let's go into the graph. I've already put the table of value, and when doing it, place and place indicate on the top of the graph. I don't have time for that one, that's why I didn't put anything for it. Indicate at the top that's the scales you're using. For this place, the scale we are using is actually for the y-axis. Now you're going to say 0.1. You're going to say, you start from the centimeter. You say 1 centimeter. 1 centimeter is actually one big box, right? So one big box, 1 centimeter. You say to represent. Now in the scale we use 0.1 units, but in this case the unit there is actually length, right? Meter, so it represents 1 meter. Now the next thing that's for the vertical axis, right? And the second one is 0.45. You're going to start with again centimeter, right? 1 centimeter, which represents 0.45 seconds square, right? on that place there. This is 0.545 there. So you write it bold here and make it clear for easy understanding, right? So now let's go in and locate their points there. So now let's start with L, which is the simple one. I think it's very easy. So the first one we have on the let me get different color. Blue. I think blue is okay, right? Yep. So the first one is 0.1. It's actually this. Put a pen there, right? So the first one is 0.1, which is this place. The second one is 0.2, which is here. This thing is very easy. The third one is 0.3, fourth is 0.4. It's too easy. That'll come. And the fifth one is 0.5, sixth one is 0.6, seventh is 0.7, eighth is 0.8, the ninth one is 0.9, the last one is 0.10 there, right? So I think this one is very easy. So the problem is on the horizontal axis. That's for the t-square axis. Now let's go now. So we said first our b was of b is equals to the first term divided by the number of boxes there. So now the first term is actually 0.45 and divided by number of boxes, which is actually 5 in this type of graph. So b is actually equals to 0.45 divided by 5. I have 0.09. So I'm going to keep that and let me write it with my pen here. This is equals to 0.09. So I'll be using it, right, as usual. So remember the formula. Let's say p is actually equals to the value minus the last time divided by p there. So this is what we're going to be using, right? So but I think I should clean this pen so our graph will be clear, right? I'll clean them and thank you. So it's clear now, right? So I'll be using it on my head. I'll be just pressing calculator because we already know the formula, we know everything. So b is 0.09 already. So the first value is actually 0.56. 0.56, there's no 5, but there is actually 4. So I'm going to take 0.45 as the last term there. So 0.56 minus 0.45, I have this divided by 0.09. I have 1 point. I'm going to count 1 and 0.22222. It should be here, right here. Thank you. Just close there. So now the next one is actually 6.7. Now the last no, I'm picking different value. This is not what I'm using. The next one here, I'm picking the scales of different in here. Sorry. So the next one is actually 0.94, 0.94, right? 0.94. And now the last is actually 0.9. Thank you. Minus 0.9 and divided by 0.09. I have 0.444444, so it's not just close to the middle, right? So not up to 1, but just close to the middle of the 1 here. I think that place is cool for it. So now let's go to the next one. The next one is 1.30. 1.30. Now the next, oh, it's less than 1.35. Now this is not the last time. 0.9 is still the last time. Grab how the thing works. If you say reach 1.35 or 1.36 like this, we're going to use this, but it's less than this one, so I'm going to continue using my last time. I love these ones here. I love this example. Hope you can see it. So this was 0.07. I have 4.4444, so I'm going to count 1 1 2 3 4, then 0.4444, that's in the middle there, right? The next one is actually 1.77. Now 1.77, which one will be the last time? It's actually less than 1.8, so 1.35 will be our last time. 1.35 now divided by 0.09, it's actually 4.6666. so we're going to count from the 3. This is actually here, right? So we're going to count 1 2 3 4, and now it's actually more than the 5 here. Thank you, that place is okay. Now the next is actually 2.10. 2.10. Let me remove this thing here. I think 2.25 here, so it's actually, this one is greater than 2.10. so the last time will continue to be our 1.8. so 2.10 minus 1.8, get this divided by 0.09, I get 3.3333. We're gonna count 1 2 3 here, right? 0.33333 will be here, so let me pick it here, right? Thank you. Oh, so now the next one is actually 2.56. Now 2.56 should be less than 2.7, so our last time is actually 2.25. now this one is 0.09. I have 3.4444 again, so I have 1 2 3 4. no, we don't reach 4. It's actually 3.444. so here I'm gonna pick my 0.444 here. Thank you. Now I'm going to go for the next one, which is actually 2.92. 2.92, yep, it's less than 3.15, so this 2.9 and 2.7 will be our last time. 2.7, so 2.92 minus 2.7, get this value 0.09, I get 2.4444, so 1 2, so now 4444 will be here. I love it. So the more we continue doing, the more easier it is. That's why I keep on doing it there. I don't want us to stop until do it all right. So this is how you face it. Very easy to do it, very fast and cool. So the next one is actually 3.24 minus the last time 2.34 is actually less than this guy, so I'm going to pick 3.15 as my last time. So 2.24 minus 3.15, I get this divided by 0.09, I get 1 dot. I love this guy, so I'm just bit on the 1, so this is where we're going to cut our 1 there. And again, I will have the second to the last, which is 3.6561. Now 61, yeah, our last time will be 3.6, so minus 3.6 divided by 0.09, so I have 0.1111, even less than, so very close to this place, right? Very close, is not even up to half. So now the last time is actually 4.08, right? 4.08 minus the last time for this last one there, 4.08 minus the last time will be actually 4.05, because it's actually less than that, because 4.5 is greater than it. So I'm gonna pick 4.05 minus 4.05 divided by 0.09, I have 0.33. So just here. So that's cool for it. I think it's just to get the last time, that will be the easiest thing to do, right? Once you grab that, I think you'll be fine with it, right? Let me show what we did. Let me push. This is a problem I'm having with the phone, right? It's not going to select for me what I want. You see it's bending. So, but that's what I mean here, right? Actually, it's still bending down, right? So this is how you continue, you do it, right? Where the other points, this one also, this is actually bending and wasting this for this one, this for this one, this for this one, and this for this one, this for this one, this for this for this one, right? If it is a point, it will be very easy for me to draw this thing, right? I'm drawing it to the phone and it's not giving me the straight line, right? So all of these things, you just cross it there, since they are on the points there, right? So your points will be somewhere around this point, and this place for the second one, the third one this place, for fourth one is actually this place. Remember, the thing is shocking us. Some of them are wrong, I have to, but sure, we're gonna monitor it. So you can see how the graph look like. So another thing I want to discuss is that for the graph, we know in secondary school they ask you to draw it and make at least most of the points should be touching the line you would draw. This is actually wrong. It's actually wrong. Yeah, it's wrong. For O level, maybe it's correct, you can go with it, but it's actually wrong. To draw a graph, you actually draw a line that is as in almost close to all of them. All of them are as in get the closest distance they can to the thing. So that other also will, as in, let me say equal, or let me say a union of all of them, the closeness of them, the closest of the union of all of them. Yeah, it can be far from it, from Mr. A, but if you actually push it close to Mr. A, Mr. B will also go further away from it. So you actually put it in the middle between Mr. A and Mr. B. Understand what I mean there? So that line should not be partial, right? Draw a line that will be very close to all of them as possible. It must not touch anyone. It may touch two, it may touch one, it may touch none, it may touch all of them. As in mass graph, you can touch all of them, so no case on that. So what I mean is that just draw a line that can be among, that can be close to like possible. Don't satisfy yourself with the line that they touch a tree, because that's where we got something wrong. Because if three touch on the same line, that's where your graph sometimes will bend towards them, right? So look at it, look at how I'm going to draw this thing. So if I'm to draw this thing, you can see this thing actually bend inward here. So I'm going to draw something like this. You can see, yeah, you can see, can you see those three are in this side, and those three also, those ones are there also, they are pointed, so I have to put it close here. Yeah, so this is okay. I've actually released it, but the thing now shifts more, right? But that's not actually where I want it to be, right? Should be like somewhere this that's it. That's the way the phone looks too. I cannot draw a line. Immediately I remove my hand, the thing will shift more, right? But you understand what I'm trying to do here, right? I didn't mind touching this three. I didn't mind touching this three or touching this three, right? What I need is actually a line between them that will be very close to other from this side and other from this side will be equal, right? As in distance between them will be very good for it. And that's all for your graph. And you can see how we do it. First we start with the introduction, we discuss on the uses of graph, also discuss on the mass graph, which are very simple, the scale and the distance are easy to plot them on the graph, just checking them. And now we go back to we went also and discuss on a physics graph. That's the real world, when you do the practical yourself and plot it, when you get values that are not their whole numbers, they are in decimals like that, so they are very hard to do it. So use formula to get it fast, and you can see how I'm using formula. I just count 1 2 3 3.5 and 3.4444. I'll just say 1 2 3, then 4, I'll put it in the middle. If I get like 2.3, I'll just say 1 2, then 0.3, then I just put close to the middle. Get 6.5, let's say I get 4.5, say 1 2 3 4, then 1.5, I just check the middle, right? Very easy. The formula is just to help you to count it at once, 1 2 3, instead of pressing your calculator saying 1, add it again, 2, add it again, 3 again, add. You understand, right? Instead of doing that, the formula will help you to just do it at once. So your own is just to count it. And remember, table of value is a scale. Bringing out scale is the most difficult thing to do, but it's actually useless. What I mean is that any scale you use, you're going to get your answer, provided that you are that much accurate and strict to locating your numbers there, right? And always use 2 decimal places if your table of value are in 2 decimal places. Don't use a table of value with 3 decimal places. If you use a scale, don't use scale with 3 decimal places. So if you use a scale with 3 decimal places, it's going to be very, very hard for you to do it. Well, there are some graphs that are very very, very small, and you really have to use 3 decimal places or somehow like that. But for simple pendulum and other things like that, you don't need to, right? So that's all for scaling. If you want to bring out the scale, you can. Waste your time, learn how to bring a good scale. But any scale you bring. That's what I want to tell you, right? Anyone you bring, such that the greater number should not be outside your graph. That's why immediately you're giving your graph and your table of value, first count the boxes in your graph and the biggest value in your table of value. Now pick that number and divide it. You know the biggest number. If that biggest number enters, all of the numbers will enter. So we're just concerned with the biggest number. We need to deal with it first. So when we take the biggest number and now divide it with the number of boxes you have, immediately you divide it, the number you get is either you use that number or you use number greater than that number, so that your graph will be compromised. If you use smaller number, the gap will be very big, that your greater number will be outside your space for your box. It will be greater than the box is there, right? So always remember, either you use the same number scale, or the same number as your scale, or you use a scale that is greater. For example, the one we just finished, I press 4.08 divided by 10, I get 0.408, and I end up using 0.45 as my table of value, which is actually greater than 0.408. So I can never use something greater less than 0.408 for that. And also, I think that's all for today, and thanks so much for watching. I wasted a lot of time, but I just believe that yeah, graph is well understood now, right? Thank you.